Okay, welcome. So this is the JEE Advanced level problem which is taken from chapter Simple Harmonic Motion. So see what is the question. Figure shows a wedge block of mass m placed on the smooth surface and is kept on contact of two unattached springs of force constant K1 and K2. If springs are constrained to deform along length only, find the period of small oscillation of wedge on horizontal plane. So this is the given diagram of the given question. So here you see, here are the two walls, and these two walls are smooth surfaces, means the friction is 0. Okay, and then there is a wedge. So this is the block of mass m, and it is attached to two springs. So both springs are different. How? See, this is the force constant K1 and it have force constant K2. So both are different, and they are attached to this wedge of block mass m, and the angle of this is inclination is theta. Now what is the question? We have to find the period of oscillation. So before finding the period of oscillation, we must know how it will move, how it will oscillate about the mean position. So now you see, since the two springs are not fixed, means if we'll displace this block towards left, so this K2 spring will be detached. If you'll take this wedge this side, so this will remain as it is, so it will be unattached. So when it will come to left, K2 will not influence the motion. If you'll take it to right, K1 will not influence the motion. So let us do it part by part. So always remember my words. Whenever it is asked to find the period of oscillation, you will find many questions in JEE Advanced. So whenever you want to find period of oscillation, always try to find this equation. What is that equation? A is omega square x. So A is your acceleration, omega is your angular frequency, and x is your displacement. So how will find time period then? So time period is 2 pi by omega. So if you know this equation, you will know omega, or if you know omega, you will be able to find time period. So whenever any question is asked related to time period, follow this methodology. So now how we'll do? So first we'll do displacement towards the left. So this is my surface. So this is my fixed surface. So I cannot change this position. No. So this is my smooth surface. Or I am assuming currently it is in this position. This is my current position. Now I am displacing it towards the left. So अभी कैसा हो जाएगा? ये ऐसा हो जाएगा. So now my wedge is in this position. Okay, and originally it was in this dotted position. So our this K2 spring will remain as it is. इसमें तो कुछ चेंज होगा ही नहीं, बिकॉज ये तो अनअटैच्ड है. बट दिस K1 स्प्रिंग विल बी कंप्रेस. सो अब कैसा हो जाएगा? ये ऐसा था, अभी ऐसा हो जाएगा. सो नाउ यू सी, वी नो स्प्रिंग फोर्स कैसा होता है. स्प्रिंग फोर्स इज माइनस F इजिकल्स टू माइनस KX. दिस इज द इक्वेशन. सो दिस इज द स्प्रिंग फोर्स, K is the constant and X is the displacement. So I'm assuming this is my displacement along the spring, that is y in this case. I am assuming, and I have taken this displacement x. इसको मैंने इतना डिस्प्लेस किया, तो ये वाला पॉइंट भी इधर आ जाएगा, तो ये भी क्या हो जाएगा? x. और ये क्या गिवन है? थीटा. तो अगर ये थीटा है तो ये क्या हो जाएगा? ये भी थीटा हो जाएगा. So I want to find what is the displacement in the spring when I displace the wedge by distance x. So if I'll make this triangle here, इसको थोड़ा सा एनलार्ज करके हम बनाते हैं, तो ये ऐसा बन जाएगा. So this is my theta x, and this is my x, and this is y. So we can find simple relation. What is the relation? Trigonometry. So sin theta is y by x. So y will be equal to x sin theta. I hope this much is understood. Now this is the displacement. So this is the displacement in the spring. So what will be the corresponding force? So corresponding force will be, आप जानते हैं, F is equals to minus K into displacement. So K is your K1 and displacement is X sin theta. So this one is the force, let us call it F1. So F1 is the force applied by K1 spring on the wedge. So what will be the direction of this K1 F1 force? Will be along the length of the spring. So this is my F1 force. So if I make the free body diagram, this particular point कैसा हो जाएगा? Like this is my wedge and this is F1 force, spring force, and this is theta. This is my theta because this is my theta, correct na? So what now, I will just take a component of it. So you see this component will be, if this is theta, so this will be also theta. So this one will be F1 cos theta and this one will be F1 sin theta. Okay, so now you see this F1 cos theta will not affect the motion because this is towards the ground, towards this surface. So our motion is happening in the horizontal direction, not vertical direction. So we will not take F1 cos theta, we will take F1 sin theta. So so F1 sin theta. So F1 sin theta will be equal to this is the net force. So this is equal to mass into acceleration. And because here it is restoring force, acting as a restoring force, I am putting minus. Now what is F1? हमने यहाँ पर फाइंड किया है. क्या है F1? K1 x sin theta and already there is one more sin theta is equals to mass into acceleration. So our equation will be K1 x sin square theta ma. So मैंने आपको बताया था कि कभी भी टाइम पीरियड निकालना है तो क्या इक्वेशन निकालना है आपको, a इज इक्वल्स टू माइनस ओमेगा स्क्वायर एक्स. तो यहाँ से उसको फाइंड करो, क्या हो जाएगा, एक्सेलरेशन कितना हो जाएगा, नेगेटिव ऑफ K1 साइन स्क्वायर डिवाइड बाई m, ये कैपिटल M है, बाई x इंटू एक्स. सो नाउ जस्ट कंपेयर दैट इक्वेशन विथ दिस इक्वेशन. सो इफ आई कंपेयर, ओमेगा कितना आ गया आपका, ओमेगा स्क्वायर आ गया K1 साइन स्क्वायर थीटा डिवाइड बाई कैपिटल M. सो ओमेगा आ गया आपका, तो ओमेगा कितना आ जाएगा, ओमेगा स्क्वायर ये हो जाएगा रूट हो जाएगा. और अगर ओमेगा आ गया तो टाइम पीरियड निकालना तो बहुत ईजी है, बस इसको इधर ले जाओ, इसको इधर ले जा लो. सो 2 पाई हो जाएगा आपका m बाई K1 साइन स्क्वायर थीटा. Is it correct? So this is the time period. Okay, now what is the time meaning of this? This is the time period if this spring is not there, because अभी तो ये फोर्स लग रहा है ना, to complete one oscillation, this is the time period. But in our case, due to this only half oscillation will take place. What does it mean? यहाँ से यहाँ आएगा, देन यहाँ पर आएगा. द मोमेंट इट विल कम टूवर्ड द राइट, इसका इन्फ्लुएंस जीरो हो जाएगा, इसका इन्फ्लुएंस सिर्फ रहेगा. सो टाइम पीरियड हम जो लेंगे इसका हाफ लेंगे. सो T1 विल बी अवर पाई रूट m K1 साइन स्क्वायर थीटा. सो दिस इज माई पहला टाइम पीरियड, फर्स्ट टाइम पीरियड. नाउ सिमिलरली आई विल फाइंड फॉर द सेकेंड, बट सेकेंड इज लिटिल ईजी. हाउ इट इज ईजी? Now if we displace it by x, what will be our time period? We can directly find the formula. Using the formula we know it will be m by k2. This is our time period t2. So we want to find total time period. So total time period is simple, you add t1 plus t2. So just pi m k1 sin square theta plus pi m k by 2. So this is the time period we want to find. So I hope this is clear to you. Thank you.